Hello class, today I'm going to extend the previous homework we had using Fluent, and it is going to be much more interesting. Let's start with SolidWorks. I would like to draw a heat sink with one fin and fluid around it. So it's not like the previous homework we had, just we considered solid part. This time we are going to have solid and mechanical, solid and fluid part. Let's open new document. It is going to be a part and front view. Again, let's start drawing a sketch. Finish, and I'm going to extrude it this much. Done. Now because I would like to have fluid around this part, I want to have a drawing to cover this portion. So let's create a surface a bit above that top side, so maybe here would be good, and go perpendicular to that, and I'm going to draw a rectangle to cover that part. And let's see, rectangle, and I am going to extrude it, but first of all the direction is wrong, so I'm going to change the direction using this button, reverse direction. Okay. The second one is I want to have two different parts, one the solid one and the one I'm drawing is going to be fluid, so I don't want to merge them, so I uncheck this merge result. The third point I need to be careful is I would like to extrude this surface up to this area. I don't want to cover all area and have this solid inside it. So we have one option for that, which is up to next, and it is going to automatically extrude up to next. When we have extra solid here, it's going to stop there. Done. We're done with it. Now you can file, save as a SolidWorks part or IGS file. IGS file is the general file. Usually it's easier to work, and you can import this IGS file for any other softwares, for example 3D printers, AutoCAD, others. Okay, you can save it here. Done. Let's go and open our workbench. First thing, you need to import the geometry you already draw in the SolidWorks. So right click over it and browse it from IGS file you saved. I use this HS IGS file, which is the exact drawing we had. After importing, you're going to see this red check there. Then you need to start meshing. Let's see how meshing is going to be done when we have two different objects. Automatically, ANSYS understands we have two different objects there, and they have different colors. If you open geometry, you are going to see we have two objects. You can rename them. Usually when you open as a default, it's part 1 and part 2. You can right click and rename this object. This is the upper side, which is going to be a fluid. So I renamed it and named it F as a fluid. And for the solid side, it's a heat sink, and I renamed it as HS for, which stands for heat sink. Then you can check the connections because we have two objects here. If you open connections, you are going to see ANSYS automatically recognize this connection. We have two objects with this connections area. So you don't need to apply these connections. If ANSYS couldn't recognize these areas, you need to manually import this using this button. Anyway, and then I start meshing. What sizing I use? I would like to have a uniform mesh, and the relevant center is fine. So it is going to generate something like this. The next step is putting some names, because we know that Fluent, we need to specify some names for different parts, which is going to make everything easier for us to understand later. Okay, let's see. I defined 3 names, one for front and back walls. So this is front wall, back wall. I selected using control, so like this, control, next side, control. So I selected all these surfaces and right click, create name selection, and I named this front and back walls. The next one is inlet. So I decided to have air coming from left side and right side into this heat sink with one fin. And finally, the outlet is going to be the top side. So my plan for this homework is having naturally cooling objects. So this heat sink is going to be 35 degree, and air or room temperature around this heat sink is going to be 25 degree. So if you start simulating, we expect this heat sink with 35 degree gradually cool down and heat up the air around it, and air after heating up is going to have a less density and getting lighter, and it's going to rise around this fin upward. And by passing time, we expect to have lower temperature inside this fin till reaching room temperature. Okay. One more point. I can define the type of material I have. So select the fluid part and go to the material. Here you can select fluid here, and for HC you can come here and select solid. Later Fluent can understand, okay, which one is which. Then we open setup. Okay, I already opened it, so let me open it again. Okay, you need to assign double precision, and it is going to be parallel solver with 4 processors. Okay. Now Fluent is importing everything for us. Okay, you can see everything here. This is my heat sink and the fluid around it. It is going to be a transient flow, pressure based, and turn on gravity, and it's negative y direction. We should have 9.81 acceleration, which is the gravity acceleration. Okay, Now let's go to the model, turn on energy. You need to check this energy equation to turn it on. For the material, again, we are going to use the default material. For the air, I'm going to simplify it. So go to the density and select incompressible ideal gas. I already explained why incompressible is easy to deal with it and we prefer it. And this is going to be natural convection. So we need to activate natural convection case too. Let's go open zone. We are going to have two zones, fluid and heat sink. So as you can see, fluid F is, we need to define the type here, fluid. If you don't define it, sometimes it's going to show you as a solid, so it's better to define it here. And for the heat sink, it is solid. And you can check it again. It is aluminum, which we decided to be there. Then you need to go and open operation condition. Gravity is already on. Business parameter is about natural convection. Later I'm going to explain in coming weeks. And you also need to turn on variable density parameter here. Turn on this parameter to have natural convection here. Okay. Now let's open boundary conditions. As you can see, the names we define in meshing section are here. Inlet, let me highlight this one. Inlet is going to be left and right side, and I change the type of inlet to pressure inlet. So select pressure inlet. For outlet, the top side, I decided to have pressure outlet, and that's it. And let me check operating condition. We already activated that one. For the mesh interface, remember we had an interface which ANSYS automatically recognizes, and this is the interface between solid and liquid. You need to open the edit part and make sure you couple wall and fluid. So check this coupled wall and liquid, which means we are going to have a heat convected from solid to the fluid. So we made sure of the mesh interface. Now let's go open methods. Because we have solid and liquid, so the scheme is going to be coupled, which can work and simulate solid and liquid both. And for the pressure, you have two options. You can select body force weighted or Presto. I here selected body force weighted one. Happy with this one? Go for calculation activities, create solution data, and as you can see, I selected, let me double click this one to show you what I did. I selected the type of the output I would like as a CFD post compatible, which is going to be readable for the ANSYS later to read. Select fluid side and heat sink side, all the surfaces. And for the output, I would like to have pressures, velocities, and temperatures. We have many other options. You can select if you want to have those data. It is going to save for you. And I selected every 10 time step to save these data. I don't want to have every time step, which is going to be a lot of data. So every, for example, 10 time step would be enough. And you need to browse it and say, where do you want to save that data? I went to my desktop, and for my test natural, and inside this folder, I decided to save here. Be careful when you want to save. This is the address you want to save, but you need to make sure you delete this one and put a name here and then OK it. If you don't say it, the address is going to be your default address for the saving, which you don't want it. OK it, and then press OK to have this data saving for you during the simulation. The next step is going to be initialization. This time I selected hybrid initialization, and after initializing you need to patch it. Patching is useful for initial conditions. You know how to apply boundary conditions here, but for initial condition you need to patch it. So because I know that initial temperature of the heat sink is supposed to be 35 degree, I click temperature, put 35 degree and patch there and close that one. Okay, so after patching I started running. The time step size is 1 second. It is really large, but yeah, I decided to use this large time step, and the number of time step for this simulation is going to be 1000, and the maximum iteration 20, which means if it couldn't, the answers couldn't converge, it is going to try 20 times. If you couldn't converge, it's going to go next step and it's going to leave it. If it converged earlier than 20, good. If it couldn't, just repeating 20 times and then leave it. Okay, let's see the results. So what I did, I drag results section here. I could use this one, but I usually prefer this one. Double click over results, and open it. You need to browse to the folder you saved your data. I saved in test natural inside this data, and I'm going to do the last one and open it. Let's define a plan. For example, here, apply. This is the plan I want to have. Temperature. Let me move it a bit further. Okay. And let's have a temperature counter. So variable is going to be temperature, where on the plan I just created, plan 1. Let's apply it. Let's go perpendicular to it, and you can see what is the temperature. Initial temperature was 35, but now it's 31 degree, and room temperature is 25 degree. Let's see what was the initial. So you can drag this to have results for different times. So after 10 seconds, this is the temperature. This hot area is 35 degree, and then we are losing this temperature, the hot temperature, to the cold air, which is 25 degree gradually, and still we have 35 degree here, but as time passes that area disappears and temperature decreases. Let me play this one and show you how temperature moves, and check out the color of this fin. It's supposed to lose temperature because it's like having 35 degree fin or heat sink on the table with the room temperature 25. So as you can see, we are losing temperature and the heat sink is getting colder and colder. If we wait and simulate much more, everything is going to finally be blue and 25 degree. If you want to save this video, you can come here and go to option and go, for example, HD video. Okay. did I click? Advanced, quality high. Let me show you the result files here. Okay, it's enough. Let's check the velocity counters. Later you can save videos. Let me make it perpendicular. Turn off counter, vector. I would like to have vector at plan 1, which we defined. Yeah, it's not that much clear. Symbol, let's go a bit larger. Now you can see what's happening here. We have cold air coming toward the fin, left side and right side, heating up. As heats up, it gets lighter and goes upward. And you can see we have highest velocity at the center or at the top. And interestingly, we have a blue area here, which is the zero velocity. So we have a circulation here. You can see we have a circulation and very low velocity area. So if your fin thickness is very small, this area would be very small, and you have much more efficient airflow over that. Let me show you the streamlines too. So streamline from inlet. Where is inlet? Inlet. Apply. Let's turn off the vectors, and this is the streamlines. So airs with low velocity comes here, and gradually when it gets closer to the fin, we have much more higher velocity. As you can see, the red side is the higher velocity. I can increase the numbers to, for example, 100, and you have a denser stream function with more details. Okay, let me turn off this. If you want to have a temperature counter somewhere else, you need to double click it. Instead of plan 1, let's go, for example, outlet. I'm interested to see what's the temperature profile at outlet. And let's go 50. Now you can see temperature profile at the top. What about inlets? It should be blue. And yes, it's a room temperature, nothing there. And let's see for heatsink. At this moment, it is around 32.3. Let me move it to the last one. So even it's going to be lower. And here it is going to be, you can even move this plan to the left or right to have more details. For example, here. Okay. Oh, by the way, if you want to find temperature at a specific point, for example, I'm asking you find temperature at the top and the bottom of the fin at this time. For example, after 90 seconds. After 90 seconds, let's see what's the temperature. You need to select this icon and temperature here. Is going to be this. You can move it here. Let me check. It is 307 minus 273. It's 34 degree after 90 seconds. After 800 seconds, that temperature is 305, which is much lower. If I check here, it's going to be around 32 degree. Okay, thank you very much. See you next time.